Welcome back to the third part in the series about the Uni-T model UT61E multimeter. I did receive some more helpful comments on the last part. Thanks for that. And yes, most definitely something terrible has happened to this poor meter, causing the dual diode package to blow up. And yes, it is very likely that the main processor IC that does the analog to digital conversion, as well as the display driving and all that, it basically does everything, that has taken some sort of damage as well. And so I thought, before we potentially go and waste a lot of time on this meter trying to repair it, we should probably first test it for accuracy, because the 22,000 counts true RMS capabilities are entirely worthless if the thing does not measure accurately. So I got out some other meters. Here we have my UT60E. This has been my primary use multimeter for many years. And then, as kind of a special guest, we have this ancient thing. This is what they use at my university to teach the younger students and newcomers not to take digital auto-ranging multimeters for granted. So, let's get started. First, I do have a bunch of batteries in here, but to keep this video somewhat entertaining and somewhat short, I will only be measuring one battery on camera. So, here I have this huge, great big D cell, and of course, remember, this meter in the volt mode, it will do ohms. So first, let's short that out and make it measure voltages. So if we short out our leads, I don't like that. See, there is an offset. I'm shorting out the leads, so there is definitely no voltage. There is an offset being measured. So let's see what this battery says. Should be still good. So let's put this to the test. 1.3643 volts. 1.36, keep that in memory, keep that in mind. Apparently this battery is not quite as fresh as I thought. So, 1.36, let's move over to this meter, see what it thinks about it. Of course, it's not as much of a high resolution meter, but as you can see, if I short out the probes, the damn thing turns off. See, I'm touching the probes, I'm shorting them out, and this is not reading anything. So that ought to be fine. That's the way it's supposed to be. Let's see. 1.37, so I'd say that is, that's not too far off. Now let's move over to this ancient monstrosity. Let me see how I work this. Got a ground and positive or negative terminal, depending on where you set the switch down there. We are going to measure 3 volts, turn it on, and wait for it to warm up a little bit, and we should be good to go. So once again, let's put this battery here. Yep, after taking a closer look at the dial, we are pretty exactly up at 1.36 volts. Yes, you can get such accurate readings off of one of these old things. It just takes a while. So that's the first battery. Okay, so I tested various different voltages, and all of these 3 meters were showing about the same results. So I'm going to say that the volts range on this meter is most likely fine. The next thing that I want to do is going to be a little bit more complicated. We're going to measure AC millivolts. For that, I have set up my frequency generator to output a sine wave with a frequency of around 50 Hertz. That should be quite fair. We got to keep in mind that these 2 meters are true RMS, while this one is not. But at such low frequencies, that shouldn't matter all that much. So as we switch this thing over to millivolts and short it out, of course it has this weird behavior where it goes into overload for some reason. So I first want to get this meter right here. I want to get the first result from this meter, just so that we can determine what we're dealing with when it comes to the other meter. So we're going to put this into the 200 millivolts range and turn it back on again. While we're at it, we're going to put this one into the 100 millivolts range and switch it over to AC. Same thing we still need to do on that one. Okay, with that being done, let's measure the output of the frequency generator and set up a somewhat even value. Okay, so this is displaying about, let's move this output. Okay, I guess that's close enough, around about 100 millivolts, maybe go a little bit lower. 92 millivolts, 93. Does vary a fair bit. Okay, next up we're going to test the ancient meter, see what it thinks about this all. Wow, this is sensitive. Okay, let's see what it does. It should go pretty much to the end of the range. And it does. We have right around 92 and a half millivolts on this old meter, I'd say. So both this meter and this meter are showing accurate results. Now let's see what the Uni-T UT61E thinks about it all. Of course, we will have to short it out, and after that we have to manually switch it to AC. Okay, and this is showing overload. So let's hook this up. Okay, 93 point something. I'm thinking that's a little high. What happens if we short out the leads? Yeah, see, I'm shorting out the leads. We are getting about a millivolt worth of offset. Should probably take my hands away from that. This is kind of too slow, I'm thinking. Okay, so the millivolts range on this thing, I'd say it is somewhat questionable. Next up, we are going to be measuring a few resistors. I have a very low value resistor here. This is a 0.47 ohm resistor, and then I have a 1 kilo ohm resistor. So some variety. So we're going to, what the hell is that displaying right there? It's measuring a disk capacitor, apparently. Anyway, let's switch this over to ohms. And let's see what it says. I mean, even if this was only doing low range ohms, that would already be handy enough. Okay, so well, you know what? I should probably first short out the leads. See with what kind of an offset we're dealing with. Of course, if we are measuring an offset in this mode, then that's not a fault of the meter. That's going to be a fault of the test leads we're using. See, I'm not moving these test probes at all. Well, now I'm moving them. Just want to hold them with one hand. See how this is jumping up and down like crazy? That's weird. Maybe if I remove this cord? Nope. Well, I'd say the ohms range is kind of messed up. Seems to get steady now. This is kind of strange. So about 20 milliohms of offset. Let's test the resistor. Okay, so what did I say? 200 milliohms offset caused by the leads plus 0.47 ohms. Well, I'd say that's about accurate. Okay, let's test the other resistor. Let's see what this is. 0.993. That's pretty accurate. So, okay, move on to the next meter. And bring this into, well, this only has a 200 ohms range, so this is not going to be very precise. If I short out the leads, is this also going to jump around like that? Maybe these leads aren't working quite right. Okay, so I guess that jumping round of values is not the fault of that meter. It's maybe the fault of these leads. I don't know. Anyway, let's test this thing right here. 0.5, 0.6. Okay, so that corresponds with the previous result. Let's bring this into the 2 kilo ohms range, measure our 1 kilo ohm resistor. See what this does. 0.994. Well, that's good enough, I'd say. Okay, now the ancient thing. See what it says. To measure resistance with this, I'll have to bring it over to measure resistance, and then down there, so 1 ohm is down there. Now we need to zero out that scale like so. See if this also jumps around. Okay, it does. Whoa, whoa, whoa. It does move slightly. Well, that's interesting. Let's see, what kind of an offset do we have on this? Below 0.1 ohms, I'd say. Okay, let's measure this resistor, see what it does. Makes no difference. What? Well, maybe it does. Well, that's inconclusive. Anyway, let's do the other one. Let's see. This is 1 kilo ohm. Should go all the way down, which it does. So that's about 1 kilo ohm. Okay, so the result, I'd say the ohms range on this does work. Next on our list is capacitance. So switch this over. I have a 100 nanofarad and a 47 microfarad capacitor. One big value, one small value. Let's first short out these leads again. I don't know what the deal is with shorting out these leads. It doesn't make any sense to me. Anyway, let's measure this thing. That is 100. around about 127 nanofarads. Okay. Now let's move over. I have not measured capacitance on this meter in a long time, but it can do it. Short out the leads. Doesn't make any sense. Let's hook up the capacitor, see what happens. Hmm. 155, 100... keeps going down. I should probably short out this capacitor. Okay, shorted out the capacitor. Maybe the previous meter charged it. It's still going down. Oh. Okay. Hooking up the leads. It doesn't even make a difference. I do have it hooked up correctly. Okay, so this doesn't work right. Which is not a surprise. This meter is not really a very good meter for measuring capacitance. Anyway, let's try the old one. Yes, even this old one can measure capacitance. Just have to switch it over to do so. And we first have to do nanofarad, 100 nanofarad. Okay, so we're about the right mode. And what does it say? It's a little over 100 nanofarads, so I'd say that is good. That's accurate. That corresponds with the measurement of that meter, at least. Okay, let's switch over 100 microfarads. Our zero adjustment is still correct. That's important. Okay, and well, that is about 50 microfarads. Let's try the meter in the center once again. Maybe it just doesn't like small capacity. Switch it over to big capacity. See what it... oh, that's wrong. There we go. Now shows 90 microfarads. Shorting out the leads doesn't do anything. Hooking up a capacitor doesn't do anything. So looks like we just figured out that the capacitance measurement mode on this meter is broken. Let's try this, the actual device under test. See what it thinks. The auto range is quite handy. Overload. Yeah, 50 microfarads. That's what we just had on the analog unit as well. So I'd say that works. And the next thing we're going to do is frequency. I have the frequency generator still set up. It's now set to around 100 Hertz. Let's hook up the first meter, see what it measures. Yep, that also corresponds with what my frequency counter says. That's fine. Let's switch over to duty cycle. Should be around about 50%. It is a sine wave after all. I'd say that's good enough. Okay, this meter can do hertz as well, so let's do that. Haven't done that in a long time either. Oh, there we go. That's hertz. Kilohertz it says in the display. Let's switch over to a square wave. Maybe that's easier to measure. Switch over to a higher frequency. We are now at 1 kilohertz. Nope. Okay, well this thing doesn't work either. And the old meter, well, one of the few things that it can not do is measuring frequencies. So the frequency counter, well, we can try that once again, since I have now set a different frequency. So the frequency counter says 0.975 kilohertz. Let's see what this meter says. If I connected, 0.975 kilohertz. That is correct. Okay, so measuring frequencies does work. Well, the next mode on the meter is the microamp range. However, I don't have anything that would generate such low currents. So we'll have to skip that, go straight to milliamps. Of course, our plug goes into the milliamp jack, and we'll have to short it out so that it'll actually work. If I short out our leads without touching them, preferably. Let's see, there we go. Okay, well, you can see we're getting quite a bit of an offset on our display for some reason. So anyway, let's hook this up to the bench power supply. Bring this into the constant current mode, if we can, that is. Quite a touchy control. Okay, that's around about 100 milliamps that we are now driving through the meter. It does not exactly correspond with the reading of the meter on the bench power supply, but that's not really an accurate meter. It's only class 2.5. So let's now switch over to this meter right here. We're going to do 200 milliamps. Bring this all over. Milliamps and 108. That's somewhat different from what this thing said. Measure this old unit over here, see what it thinks. For that we're going to bring it... Oh. Okay, I got confused there. It does have a 100 milliamp measuring range. It's just 0.1 amp on this thing. And... okay, well on this one we only have about 98 milliamps. See, so we are getting quite a variety of different readings. So we got 98 on this. We have 94 on this. Seems like our current is going down. Do this again. 90, 95. It's about 94 on this, so it seems like this is about a milliamp low. That's acceptable. Let's test this thing once again. Preferably using the right jacks. And shorten out once again. Okay, we're now down at 82. So this is definitely low. Or is it 82? Switch this over here. 87. Well, it is going down, but this thing was still quite a bit lower. Anyway, so let's just say the milliamp range is questionable. And we can continue straight ahead. No more need to short this out because the amp range actually works. So we're going to go and we're going to drive 1 amp through this thing. Okay, that is 1.06 amperes on this meter. Switch over to the 10 amp range on there. Get this adjusted and connected. 1.05. That's pretty accurate. And on this one, go up to the 1 amp range and move these leads over. Ooh. That is definitely reading too high. That's about 1.1. Also on there, it seems. So that is a little high. Try this one again. 1.05. So this one seems to be a little bit too high. Well, this one is accurate. Okay, I don't want to torture my bench power supply for much longer. And I don't want to torture you for much longer either, so thank you for watching. And while the meter in the center has an automatic power off that will kick in eventually, you will have to remember to turn off the other meters manually, like so, and it is very easy to forget it on this meter because it's only that little knob right there.